Hey there guys, and welcome to my first ever real video. Today's video will be on exponents, and the first thing we're going to talk about are the rules of exponents, or in other words, the laws of exponents. So first off, we have the multiplication rule, which basically says a to the power of x times a to the power of y equals a to the power of x plus y. So at first this might look a little confusing, but once you actually start using numbers in the actual equation itself, it'll be really easy to recognize. So basically, if we have 2 to the power of 2 times 2 to the power of 3, that'll equal 2 to the power of 2 plus 3. So all this is saying is when you're multiplying two numbers that have the same base, you're going to add the exponents. So it's really easy. If you were to simplify this, it would just be 2 to the power of 5, and that's basically where you stop, unless you are told to write it as a number. And then the division rule is saying almost the same thing, except you're basically changing what property you're doing. So a to the power of x divided by a to the power of y equals a to the power of x minus y. So in most cases, this will be displayed as a fraction, but it's basically saying the same thing, so we'll use the same number. So 2 to the power of 2 divided by 2 to the power of... Actually, I'm going to change this to 1, just so it's easier. Saying 2 to the power of 2 minus 1. And then again, simplify that, just 2 to the power of 1. Same thing as saying 2. But in most cases, you'll see it as something like this, where it'll be like you subtract your top number from your bottom number. Same thing as writing it this way. But again, dividing by the same base, you subtract your exponents. So those two rules are pretty easy to memorize. They are kind of similar, just a tad bit different, but they basically say similar things. Okay, so our next rule is going to be power of a power. So basically, whenever you see this, it's going to be written like a to the power of x to the power of y. And when you solve this, you're just saying you're going to be multiplying the exponents. So a to the power of xy. And when you actually see it, it'll be written like something like this, like 2 to the power of 3 to the power of 4, which would be 2 to the power of 3 times 4, or 2 to the 12th. So this one's pretty simple. It's kind of like the division and multiplication rule, but instead of adding or subtracting, this one you multiply. So that should be all for that one. So our next rule is going to be power of a product. So whenever you see it, it'll be written in this format: AB to the power of x. And this is basically just saying it's almost like distributive, where our x is going to go to this one and our x is going to go to this one. So it'd be ax, bx. It's pretty simple. So like let me think. Let's do like 2x, right, to the power of 3. So this would be 2 to the third times x to the third. And when you're simplifying this, obviously you just do this. So 8x to the third. So that's basically all that's saying. It's almost like distributive, where you just distribute that exponent to every term inside the parentheses. So our next rule is going to be power of a fraction, which is really similar to the last one, power of a product. So whenever you see it, it's going to be a over b to the power of x. And it's literally the same thing as the other one, except this one's going to be given to you as a fraction instead of just a simple term. But it's basically saying that this exponent will affect both of these. So it'll be like 1/3 to the power of 2, and it'll be distributed to each part of the fraction. So again, this will be brought to that power, and this will be brought to that power. And obviously you can just simplify this. And that's literally all. So on to the next one. So our next two, I think they kind of go hand in hand because they're kind of just rules about if you see a certain type of exponent. So the first one is zero exponent, and this basically says any number to the power of 0 equals 1. Extremely simple. You see any number to the power of 0, it's going to be 1. No matter what number. It could be 100 to the power of 0 equals 1, or 10,000 to the power of 0. It's going to equal 1. No matter what, it'll equal 1. And for negative exponent, this is all this is saying is if you have a number to a negative exponent, you're going to flip it and make it a fraction. So 1 over a to the x. That's all it's saying. So if you have, let's say, 2 to the negative second power, you would flip it and turn it to 2 to the second. Now, same thing would go if you had a fraction. You would flip it, but you have to make sure you're flipping the right terms. So like if you had 1/2 to, let's say if you had 1 over negative, what am I saying? 1 over half to the negative second power, you would flip it to 2 to the second over 1. Your 1 just goes away, and there you're left with 4. So later on, when I show some examples of these, you'll kind of understand how you have to flip it with a fraction. But overall, it's a pretty simple rule to memorize. So our last and final rule will only be applicable for some of you, because not everyone gets to this part. But this is the fractional exponent, which is saying a to the power of x over y equals the y root of a to x. So I don't believe you use this in pre-algebra, but once you get to algebra, you will start using it. So it's good to know, but that's all that's saying. It's basically, let's give an example. So 3 to the 1/2, right? That would equal the square root, because remember our 2 is going on the outside here. So our 2 is y in this case. So our 2 is going to go on the outside. We put our whole number, or our number that is attached to the power, inside the square root, and then we put the power, or the numerator of the power, onto our main number. So in this case, it's just 1, so it doesn't really do anything. So it would just be the square root of 3. But in some cases, you will have a numerator that is greater than 1, so it will affect your number on the inside. But basically, that's all of the rules. So now we're going to get into some examples. So this is going to be our first example problem. It is saying 15x to the 6th over 3x to the 2nd. Now, if you want to pause this and answer which property and then actually solve it, you can, because I'm about to solve this, and if you want some practice, you can just solve it before I do, so I don't give you the answer. So basically, this property is the division rule. So let's write that here, division rule. Okay, and to solve this, it's kind of easier to think about it split up. So if you split it up into 5 divided by 3 times x squared, or x to the 6th divided by x squared. Wow. And if you do this way, it's much easier to just do piece by piece, and you'll be able to see the division rule for the exponents a lot clearer. So you solve this one, 15 divided by 3, that is 5. And then x squared divided by, or x to the 6th divided by x squared. I know I keep saying that. So if we go back to our division rule, it says that you have to subtract your exponents. So in this case, it would be, this would equal x to the 6th minus 2. So we do that, and we get x to the 4th. And if we see this multiplication sign right here, that means we can just stick them right back together. And this will be your answer. So our answer is 5x to the 4th. Okay, so this is our next problem. It is saying negative 2x squared y to the 3rd to the power of 3. So basically, to solve this, we are going to distribute our 3 to each term. So me personally, I'm going to break this up. And as you can see, because of that distributing, you can tell that this is going to be power of a product. So when we break it up, we have negative 2 to the 3rd times x to the 2nd to the 3rd, and then we have times y to the 3rd to the power of 3. Okay? That does not look like a 3. There we go. So when we do each of these, you'll realize that 2 of these are actually a power of a power inside of our power of a product. So this first one, negative 2 times negative 2 times negative 2, because of the fact that our exponent is odd, our answer is going to be negative. So in this case, it's going to be negative 8. And then we multiply that by x squared to the power of 3. And like we said earlier, when you have power of a power, you multiply them. So this is going to be x to the 6th. And then same with this one, we have y to the 3rd multiplied by 3. Or y to the 3rd times 3, there. So in that case, it's going to be y to the 9th. And because these are all being multiplied by each other, there we go, you have negative 8x to the 6th, y to the 9th. And there you go. That'll be your answer. So this is going to be our next problem. It says 10 to the negative 3rd. Write using positive exponent. There should be an A in there. Write using a positive exponent. So again, this is our negative exponent rule, and whenever we see something like this, we are just going to flip it. So there you go, that'll be your answer. 1 over 10 to the 3rd. And that's literally it. I think that rule is probably one of the easiest on here, except for the 0 exponent. That one's pretty easy. Okay, so here's our next problem. This one doesn't have to necessarily pertain to the laws of exponents, but this is a problem that has to deal with exponents and how to get rid of it, I guess, or how to solve it. So this says a square yard has an area of 404 yards, let's say, because I guess the nearest yard. So what is the perimeter? And it says rounds to the nearest yard. So right here it tells us square, so let's draw a picture of this. And we have a square, and the inside is 404. What do we know about the area of a square? Well, the area equals the side squared. And if we plug in our area here, this will allow us to find the side, because we need to find the side to find the perimeter. So since we have 404 equals s squared, we can square root both sides to get rid of our exponent. So if you were to type this into your calculator and actually solve it, you get 20.09, I believe. So rounding that, that's about 20.1. So now that we have one side, we know that if we multiply this by 4, it'll give us our perimeter. So perimeter equals 80.4. And right here it says round to the nearest yard. So we know that perimeter is about 80 yards. And that right there is just how you'd solve that. So whenever you have an exponent, you can get rid of it using the square root. But you have to square root both sides, because everything you do to one side, you do to the other. And you will probably see more of this in the upcoming video when I start to solve one-step and two-step equations. So that'll be all for this video. Just wanted to thank you for watching this first one. I cannot wait to make many more of these videos. But thank you, and remember, math is delicious.